Okay, here we go. If I told you guys to write equations to be able to graph them on your calculator, we won't do this whole problem, but what variable would you solve for? You'd solve for y, and how many answers would you get? You get two. You get a plus and a minus of a square root, and then you could graph it. And so you guys know how to do that. We're not actually going to go through that whole process. But suppose you were asked to write an equation for a line, or for a hyperbola. Well, there's two types of equations. There's x squared over a squared minus y squared over b squared is equal to 1. And then there's y squared over a squared minus x squared over b squared is equal to 1. What's the difference between those two? If the x is negative, then it's a vertical. If the y is negative, then it's horizontal. So that's what we have to really kind of think about. So this says that the focus is at 0 plus or minus 5, and the vertices are 0 plus or minus 3. Do you know if it's going to be the first type of equation or the second? If you don't know, better draw it out, I guess. So we draw. Focus is 1, 2, 3, 4, 5. 2, 3, 4, 5. So I have focus points there. And I have vertices there and there. So is this hyperbola going to go up and down or left and right? Up and down. So will it be the first one or the second one? Second one. Okay? Since y squared is first and it's positive, it goes up and down. So that's the equation that I'll use. Okay? So we're going to use that one. So what I need to do now is I need to figure out A and B. So let's list A, B, and C. See what we have. Anybody know what our A value is? 3. Good. Do we know B? Do we know C? 5. How do I figure out B? For hyperbolas, we have C squared is A squared plus B squared equals C squared. And if we use that, we'll solve B and we will get 4. So 3, 4, 5. Can you now write your equation? Oh, good. The vertices always tell us A. The vertices always tell you A. Focus points always tell you C. The asymptotes are made up of A and B. In order to find B, we have to use this formula. It could say the endpoints of the minor axis for the ellipse. So major axis would be the vertices for an ellipse. Minor axis would be the B values. So let's suppose that they could tell you this. They could tell you for an ellipse that you got focus points there, but that the minor axis is 4 units wide. Well, that now you know B is equal to 2, and you know C is equal to 5. So your vertices are now out there, and you got to figure that out. So they could give you that kind of information. So you got to kind of figure it out from your drawing and stuff like that. Okay, so let's write our equation, then we'll move on to the next problem. We have, so we'll have y squared over 9 minus x squared over 16 is equal to 1. Okay, let's try the next one. Next one is significantly more difficult. This should be y equals plus minus 2x. I don't know how I missed that, but I did. If I make just a little sketch here, I know that the focus points lie here and here. So will x squared be first or will y squared be first? X squared. A, B, and C. What's A? 4. Whoop, I'm sorry. We don't know A. What's C? 4. Okay. Now this is the more challenging portion. How do I figure out what the asymptotes have in regard to the relationship of A and B? Right, it's slope. And so if this is horizontal, it will be, say, B units up and A units over, right? It'll be B units up and A units over. So what I have here is 2 is equal to B over A, my slope. If you remember from our previous page, right here, we said that if it's a horizontal one, then the asymptotes will be y is equal to plus or minus b over a times x. And if it's horizontal, or if it's a vertical, it was y equals plus or minus a over b times x. Right? That's what we said, right? So what I'm saying is we are going to use that b over a in order to help determine what our a and b values are. Now here's the problem. You write it as 2 over 1, and you decide, okay, so that means that b is 2 and a is 1. If you take 1 squared and add it to 2 squared, do you get 4 squared? No, you don't. And so that's the problem. You don't know if it's 2 over 1, 4 over 2, 7 over 3.5, 40 over 20. You don't know what the numbers are. You just know that the ratio is 2. So it's not a is 1 and b is 2. It's a is 1 times some number, we'll call it r, and b is some number, we'll call it r. 2 times that r. So, if I take 2r divided by 1r, I still get 2. So it works out for the asymptotes. We just don't know, what that ratio is. I can solve for that ratio by using this. C squared is equal to a squared plus b squared. You can see that, this is tricky. It's okay, though, we can do it. What is c squared? What is a squared? R squared. What's b squared? 4r squared. What's r squared plus 4r squared? So 16 is equal to 5r squared. Divide both sides by 16 over 5 is equal to r squared. Now do what? Square root. Square root of the top gives me 4 over square root of 5 is equal to r. I can't leave a square root in the denominator, can I? So you got 4 square roots of 5 over 5. So a is 1 times that 4 square roots of 5 over 5, which is 4 square roots of 5 over 5. B would be 2 times that, which would give me what? 2 times 4 square roots of 5 over 5 is 8. So let's just think about this. If we took that b value and divided by that a value, we would get just 2, which is, the value of our asymptotes. If you did a squared plus b squared, you would end up with c squared. So you can see that it's not as simple just writing 1 and 2. We had to figure out, that ratio there. Well, now in order to write the equation, I have to square that a value, right? Okay, so let's square this. What's 4 squared? 16. Square root of 5 squared? 5 over 25. So 16 times 5 over 25 would be just 16 over 5. Yeah, the 5 over 25 will reduce to just, 1 over 5. So we got 16 over 5. So I could write it as x squared over 16 over 5 minus, let's square the b value now, Um, 8 squared is 64 times again 5 over 25. That will reduce to what? 64 over 5. So I have y squared over 64 over 5. Can you leave a fraction in a denominator like that? No, that's a complex fraction. So so this is the last step. Instead of dividing by 16 over 5, I should multiply by 5 over 16. So what this actually is 5x squared over 16 minus 5y squared over 64 equals 1. So when you look at this problem, if you looked at this right now, you'd say, oh, well, A is going to be 4 and B is going to be 8. No. A is 4 square roots of 5 over 5. B is 8 square roots of 5 over 5. You would have to, turn this number into the 16 over 5 and 64 over 5 and then take the square roots of them. So some hyperbola is a little bit more difficult. And, we won't do too much with that. That's just more algebra, but you should know how to handle that situation. Now, I have one more problem for you where we actually transfer the center. And instead of giving you many homework problems, I just have 4. 2 where you do the equations, and then 2 where you transfer the center. And that's it. I figure you guys had enough practice with ellipses. So doing ellipses is very similar to doing hyperbolas, right? So we won't kill ourselves and overdo it. We'll just, do whatever we need to make sure we can do the problems correctly. So let's do this one. You can put the extra example on your notes, or you can put it on a scratch sheet of paper, or you can put it in your brain for memory, whatever you want to do. Okay? So this is our last step for the day. We are out of here in 7 minutes, so we got to make quick hay of this. We want to give all the important characteristics of a hyperbola. We start with the center. What is going to be the center of this hyperbola? Good, -2, 1, because they're switched. So you got to account for the x as -2 and the y is 1. So I'm going to plot that first. Well, first let's figure out A, B, and C so I know how many tick marks to make. A, B, and C. What is A? 2. B, C. Square root of square root 13. Nice job, Skywalker. All right. So let's see. I would be going 3 units from the center. So it looks like if I make a 5 by 5 and a tick mark graph, that would be sufficient. By the way, I'll be rooting for all the guys' teams during dodgeball today. Well, girls are better than guys at most things. But definitely not dodgeball. Well, they are. I mean, come on. Let's admit it. I hope all the girls get out first and the guys come back and win. All right. Okay. I'm joking. All right. So if you dodge a wrench, so you can dodge a ball, right? You've been dodging some wrenches lately? Yeah. I'm going to throw wrenches at my kids tonight so you get them practice for when they're in high school someday. All right. Okay. So we plot the center, -2, 1. Very good. And now, do you remember what I do that's different than what your book does, maybe? I make a box, and so I should go how many units in each direction horizontally? 3. 2 in the Y, 3 in the X. These always tell you which direction you're moving. You could never move 2 in the X if the 4 is under the Y. Can't do that. Okay, so here we go. So I'm going to move, let's see, 1, 2, 3, 1, 2, 3, and I'll move up 2, 1, 2, down 2, and now I can make my nice box. Once again, I'm very gifted at making dots. We will now, I'm going to make my asymptotes too. So now I've got this. Okay, I've got my asymptotes, I've got my box. Now what I need to do is I need to plot my vertices. What's up? Vertices. Do the vertices go on top and bottom of the box or on the left and right of the box? Top and bottom because this is a vertical one. Very good. I'm going to put one at the top, one at the bottom. Is that enough to now draw the shape? Got my vertices and my asymptotes, so now I can draw it. Bye, Julia. We'll miss you. So the blue shape is actually the graph. Okay? So what are the locations of those vertices? -2 is the x value for both of them. What's the y value? Good. Up. I'm up 3 for that one, and then I'm down to -1 for the other one, right? Length of the transverse axis. What's the distance between the two vertices? 4. Foci. Foci are how many units from the center? Square root of 13. So you'll take the square root of 13 and add it onto the y value or add it onto the x value? The y value. So you still have your location of -2 for x, but then you'll add -2, or you'll add the square root of 13 onto 1, and then you'll subtract the square root of 13 off of 1. And that will get you your coordinates for the vertices. Does that make sense? We've only got a minute. Minute 10. Okay, so we won't be able to finish the asymptotes, but we can tell you how to do them. Last thing, asymptotes. Asymptotes. 1 and 2. What two things do I need to have in order to write an equation for a line? Slope and a point on the line. These both pass through the center, which is -2, +1. That's my point on my line. Look at the slope. Look at my box. How many units up for the box? How many units up for the box? 2. How many units over? 3. So the slope will either be +2 over 3 or -2 over 3. Now go ahead, use y equals mx plus b, and write your equation for your line given your slope and given your point on your line. And that's how you do it. Your assignment, these 4 problems. That's it. That's it. That's it. I know you guys got a lot of homework, and it's going to continue at least till we're done with this chapter. Just stay the course. Have fun tonight. Have fun tomorrow. And make sure you get some homework done on Sunday. Okay? Dodge a wrench, you dodge a ball. Go boys! Yeah!